All right, so this is worksheet 9. We're going to talk about zeros of polynomial functions. So the definition of a rational zero is a polynomial function of degree n. So if it had like degree 6, right, it can have at most 6 zeros or n real zeros. Real zeros can be rational or irrational. Rational is anything that could be written as a fraction, right? So that includes whole numbers. Irrational would be things like square root of 7 and that kind of thing. Rational zeros are those that can be written in the form of plus or minus a fraction. Okay. The rational zero theorem can be used to determine all possible rational zeros. They don't always all work. And to find that, you find all the factors of the constant term over the factors of the leading coefficient. Is that vocabulary that we're comfortable with? Constant term means it has what? If you have a polynomial with a whole bunch of crazy stuff, the constant term is the one that has no variable attached to it, no x, okay? The factors of the leading coefficient, whatever the highest power is, the number in front of that are the leading coefficient. Okay, so if we put all the factors of the constant on top of all the factors of the leading coefficient, and we include all the positive and negative possibilities, those are going to be all the possible rational zeros. So let's practice with number 1 here. What are all the factors of, well, first of all, what are P and Q? How's that? What are the constant and the leading coefficient on this one, guys? 40 is the constant and the leading coefficient is just 1. And it's plus or minus all the factors of that. So plus or minus, what are the factors of 40? You can list them in factor pairs or you can list them in order. It doesn't matter to me. But what divides into 40? 1 does. 2 does. 4. 5. Okay, now we're starting to reach the pairs. 5 goes in 8 times, so 4 goes in 10 times, 2 goes in 20 times, and 1 goes in. If it helps you to write those, 1 comma 40, 2 comma 20, doesn't matter to me what order you write them in. Now, we're in luck on this one because they're all over 1, so we don't need to do anything tricky, okay? On this next one, we have the factors of what? 28, and it doesn't matter, we're going to do both positive and negative in a minute anyway. By the way, I should have talked about that here. We had 1, 2, 3, 4, 5, 6, 7, 8 possibilities, but there's actually 16, right? Because you could have all the positive ones or all the negative ones are possible. All right, but on this guy, we're going to have the factors of 28 over the factors of the leading coefficient of 2. It doesn't seem like it's going to do much, but it's actually going to add a few, because what are the factors of 28? 1 goes in there, what else? 2, you're welcome to use a calculator if you need to on the quiz for this. 4 goes in there 7 times, 2 goes in there 14 times, and 28 goes in there once. Once you reach a pair, if you're doing them in order, once you reach a pair, then you just have to find the other pairs. And the denominator is plus or minus 1 or 2. All right, you will have to list these all out for me. You don't have to list both the positive and negative, though, okay? You can just put a giant plus or minus in front. But what if I put these over 1? Then I just have 1, 2, 4, 7, 14, and 28. But what if I put them over 2? Does that add some other possibilities? 1 over 2. 1/2 is a possibility. 2 over 2, do I need to write that one down? 2 over 2 is 1, it's already on my list. 4 over 2, do I need to write that one down? 7 over 2. 14 over 2 is 7, and 28 over 2 is 14. So there we go. Got them all. Anybody confused? I don't care about the order, as long as you have them all there. All right. That's all we were asked to do on those. Now, this question is an example that's partway done for you. The leading coefficient was 1. The constant was 6. So we had plus or minus 1, 2, 3, and 6 all over plus or minus 1. So the only possibilities were 1, 2, 3, and 6. Then they graphed, okay? The next thing you do is you graph. So, can someone read that to me? X to the third, then what? Anybody read me this one right here? X to the third minus 5x squared minus 17x minus 6. X to the third. Thanks, because I already forgot. Then it was a minus 17x and a minus 6. I don't know why I could remember that, but I couldn't remember the first one. All right. If I graph this, I can just use a standard window, or I could change it, doesn't matter. Can you see any that you think are nice? This doesn't look nice. This doesn't look nice. That one looks like it might be -2. So if I do trace -2, okay, that one's good. You could also look at the table and see if there's one that's nice. Okay. So -2 worked. Now, do you remember what we did yesterday when we found one that worked? Remember we divided it using synthetic division? So this was 1x cubed minus 5x squared minus 17x minus 6. Tell me what to write, guys. 1, -2, -7, yes. Then I have 14, -3, -2 times -3 is +6. If it worked when I graphed it, it better come out, right? With a 0. Okay. This depressed polynomial, then, this is a -3, this gets an x, this gets an x squared. Does that factor? No, it does not. Okay? So we have x squared minus 7x minus 3. We can't factor. Does anybody remember what always works to find the zeros, even if it doesn't factor? Quadratic formula, does that sound familiar to anybody? Yeah, sorry, it's not gone. So the rule is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, as long as you have 0 equals ax squared plus bx plus c. So this is what the quadratic formula looks like. All right, so what are a, b, and c for r's over here? A is 1, b is -7, and c is -3. All right, so x equals the opposite of b would be +7 plus or minus the square root of b squared, -7 squared, minus 4, which comes with a formula, times a, which is 1, times c, which is -3, all over 2 times 1. Okay, just type in what's under the radical. Do not type the radical in. If you type -7 squared minus 4 times 1 times -3, everybody please check that you can get that correct. Is it 61? 61? Anybody not getting 61? So we have 7 plus or minus the square root of 61 over 2. Can we reduce anything there? Nope. So the other two zeros are exactly at 7 plus the square root of 61 over 2 and 7 minus the square root of 61 over 2. And there was one nice one at -2. If I go back to the graph and I find this one, find the 0 between -1 and 0, it gives me this crazy decimal, okay? The only way to get that and figure out what it is, we did quadratic and we said it was negative, what was it, guys? Okay, wait a minute, I think I need a parenthesis. +7? Was it +7? Okay, 7, this would be minus because it's the -1, square root of 61 all over 2, is that right? I'm just checking to show you that that's how it comes up, okay? It's the only way to, yuck. All right. So, moving on, list all the possible zeros of this one and then determine which, if any, are zeros. Okay, so we're in luck. The leading coefficient is just 1. So the factors of the constant are the factors of 20 over the factors of 1. So what would we get? Factors of 20, guys. 1 and 2. 4, 5, 10, and 20. Okay, so we were supposed to list that. There's the list. Then it says determine which, if any, are zeros. Does anybody remember the painful way I would have had to do this because I didn't have a graphing calculator? If it's a 0, I can plug those all in, right? One at a time and figure out which one comes up 0. That doesn't sound too fun, does it? Okay, you have a graphing calculator, so would someone read it to me? Was it an x cubed? Then what? Oh, okay. Plus 20, thank you. Actually, I think we might have been able to factor that by grouping because I think it's going to have 3 nice solutions. Okay, does that look like -2, 2, and 5 maybe? If we do trace 2, -2, and 5. Now, if all it asks for is those, you could write 2, -2, and 5. If it asks you to verify them, which it does on the quiz, do you remember how you'd verify them? What did we do yesterday? You'd pick one of them, right? You don't, if you don't want to write this down, it's up to you, but you'd pick one of them. I picked the big one because I like to get the big numbers out of the way first. Bring down the 1, multiply, add, multiply, add. Okay, now actually to prove the other two, I could just factor or I could keep dividing. 1 is 2, 4, 0, and I could even do the -2. And then the 1, -2, 0. Okay, so if you wanted to prove, you don't have to prove them all. The bit about factoring I said when I got right here, that represented x squared minus 4. So it would have factored x plus 2 and x minus 2 so that I wouldn't have had to keep dividing. Okay, it didn't say you had to prove them. I'm just reminding you here. Okay, polynomials can have zeros that are complex. Remember, complex numbers include real and imaginary. So when we say it has complex, it will include both. A polynomial function of degree n, where n is greater than 1, has at least one zero in the complex number system, which includes zero, real numbers. Okay? Any real number is also a complex number. It says that right here. If c is a complex zero of a polynomial function, then x minus c is a linear factor of the polynomial. This means all polynomial functions can be completely factored, but they don't have to be nice. Okay? If you went back to this example I did a minute ago, the one that we did quadratic formula for, this is what the linear factors would look like. X minus this, x plus this, and x minus 2. Those are really disgusting, right? Okay. So do you have this example? No? Maybe not? Yes, you do? I don't know if it's already done for you, but x to the fourth minus 24x squared minus 25. Remember when we saw an x to the fourth and it only had an x squared as the other term and a constant? We did it factored x squared and x squared. And then this one factors further x plus 5 and x minus 5. But does x squared plus 1 factor further? Only minus 1 factors further, okay? X squared plus 1 does not factor further. But if you set it equal to 0, you get x squared equals -1, and when you square root both sides, you get plus or minus, what's the square root of -1? It has a special name, I. So now we have zeros of I, -I, 5, and -5 from these two factors right here. Everybody good where those came from? So then if it wanted the linear factors, you would write out x minus I, x plus I, x minus 5, and x plus 5, okay? That's where all that garbage came from. All right, this is the conjugate root theorem. List all the possible rational zeros using the rational zero theorem. Then graph to find the zeros. Does it say that on yours? Is that little box there? Okay. Then test the zeros using synthetic substitution. When you find a zero that works, use the remainder to completely factor the polynomial. Then find the zeros. It is possible you will have to use quadratic formula or that you could have i's at the end, okay? When you found all the nice ones doing successive division, can you write that word down? Because it asks you to explain how you did this. And you need that word, successive division. Just means one right after the other. You don't go back to the beginning, okay? So eventually when it asks you on the quiz, how did you find these or prove these, you're going to say successive division. And I'm sure someone will say successful division or something, and I'll go, yeah, close enough. All right. Find all the exact zeros. Okay, we got 2 questions and we're done. All right, we're just going to do 2 questions. First of all the possible zeros, I think we should practice that again. Factors of what? What? You have what? Oh, am I doing the wrong one first? Is that what I was doing? Okay. Is it, but you just have these 2, don't you, or not? Okay. All right. So it's factors of the constant over the leading coefficient. Well, the constant here is 2, and the leading coefficient is just 1. So what are all the possibilities? 1 and 2, right? Positive and negative 1 and 2. Does anybody see what we could do if we didn't want to graph this? This actually factors. Okay? If you take out an x squared out of the first 2, and then you take a 1 out of the second 2, you get x squared plus 1 and x minus 2. But if you graphed it, did anybody graph it yet? I think it should have a real 0 at 2. Somebody need me to graph it? X squared minus x cubed minus 2x squared. And then what did it have? Plus x minus 2. Okay, if we graph it, it has one nice 0 at 2. And that's the only nice one, but that doesn't mean there aren't more. This is important for you to understand. Do you see that this only has one nice 0? But it is a cubic shape. It has to have a total of 3 zeros. The other 2 are going to be imaginary. That's why it only crosses the x once. Okay, so we're going to do the division with the 2. Or you could factor. It's the same difference, but 1, -2, 1, -2. If I bring down the 1, multiply, you get 0, 0, 1, 2, 0. Okay, so whether we did it by factoring, by grouping, or this way, we ended up with an x squared plus 1. Does everybody see that? Whether we did it this way or this way. Okay, we need to set that equal to 0 and solve. I think we just practiced that a second ago. We subtract 1 to the other side. Okay, we square root. What do we have to remember? Yeah, plus or minus and I. If it's an x squared, it has to have 2 roots. They are positive I and negative I. So what did this ask us? Both the zeros and the factor. Okay, so where are the 3 zeros, guys? Those are the factors. Yep. 2 is a 0, I is a 0, and negative I is a 0. The factors are x minus 2, x minus I, and x plus I in any order. Yes. Those are the linear factors because they are down to x's, okay? All right, one more, and we're done. Factors of the constant over factors of the leading coefficient would be the factors of 5 over 2. So what factors would those be? Plus or minus 1 and 5 is it, right? Over plus or minus 1 and 2. Now, if this was a quiz question, you have to list out what that means. So if 1 goes over 1, you get 1. If 5 goes over 1, you get 5. What else does it mean, though? Yeah, 1 goes over 2, and 5 goes over 2. And then they're all plus or minus. Okay, there's the list. Again, I think we could factor this, but let's graph. All right, this time it came out with a 2x to the 4th? No, or just an x? Sorry, what does it start with? 5th. Okay, thank you. And then what? Thank you. All right, if I clear this out of here and graph it. Which ones look nice? -1 and 1? 1. Anybody know what that one might be? It's on our list. I'm thinking it's 5/2, but we can find it and verify it by doing our division with -1 and 1 worked for sure. -2, -7. 7. Am I doing this right? 5. Oh, yeah, we need a whole bunch of placeholders. Darn it. All right. Do you want to just write them down? What was it again? -1, 1, and 5/2 worked, right? So we'd have x plus 1, x minus 1. This is important. If you wrote x minus 5 halves, it's going to be wrong. Does anybody know why? It's got to be equivalent to this. So you'd need a 2 out front. That's a big issue. If you would have divided, it'll come out better. I just didn't want to do all this placeholding. Okay, we have a negative 1. You could write this as 2x minus 5 yet, which is what we're going to get when we do the division. All right, we had a 2x to the 5th, a negative 5x to the 4th, 0x to the 3rd, 0x squared, a negative 2x, and a 5. Ooh, 2, negative 2, negative 7, 7, 7, negative 7, 7, negative 7, yeah, I did something wrong. What did I do wrong? Okay, negative 7, 7, add is 7, negative 7, add, oh, this is a negative 7, right? When you add 0, then you multiply, this is a 7, then we have a 5, negative 5, and 0. Then we'd have a 1, because we said both 1 and negative 1 worked. 2, negative 5, negative 5, 2, 2, negative 5, negative 5, and 0. Okay, my answer is totally wrong. Not really. But what's missing, there's supposed to be 5 zeros. What does this represent? That's a constant. This is an x, x squared, and x cubed. Down to that. We could use 5 halves now to divide it further, or we could group it. Do you want to do 5 halves? I'm going to move this down, and I guess I shouldn't have acted like we were done a minute ago because we're not even close. Okay, 5 halves was the other one we found. If we had kept going, brought down the 2. This is not as complicated as it looks. What's 5 divided by 2 times 2? 5. And then we get a 0. And then we get a 0. We bring down a 2 again, and we get 5 again. Okay. So what does this say? 2x squared plus 2. What can we take out of that? A 2. So we'd had a 2, and then we had that x minus 5 halves, and an x plus 1, and an x minus 1. But we still got to solve this bad boy, because there's 2 imaginary zeros. If you take the 2 out, and then you solve it, we have plus or minus I are the last 2 zeros. Okay, I did not explain that well at all. If you do the division all the way to the end, you will end up with that 2 out front, even if you write this as a 5 halves, or you could distribute it. I just want to show you quickly on the graph. Do you see here how it looks like right in there it's doing a funky shape? Doing something weird up here? That's how you know. I should have known there was an extra imaginary zeros, besides the fact that it was degree 5. Okay? No, you could write this as 2x minus 5, and then you would have x plus 1, x minus 1, x minus I, and x plus I in any order. All right, I ended that badly. All right, guys, there are 3 circled, no delta math tonight, okay? There are 3 circled problems on worksheet 10B, and you need to work on finishing up the Google Slides. Okay, I would suggest you do slides 8 and 9 tonight. 8 is a puzzle about multiplicity. You just drag the zeros over and make a little picture. And 9 is just a little bit of typing, like you talk about multiplicity on that one as well.